Next, we want to find the zeros, which is basically the values for x, the values of x for which f of x is equal to 0 of the polynomial function. You're probably familiar with it as like the X intercepts. Okay, there's also going to be the roots, the zeros. The terminology is going to sink in with you as we go. Okay, so we have our function. F of x is equal to x cubed plus x squared minus 42x. We want to, anytime you find x intercepts, we what? Let y equal 0. So basically, and remember we recall that this is the same thing as y equals, so basically we want to set our function equal to 0 and solve. So x cubed plus x squared minus 42x equals 0. Okay, this is, what do they all have in common? X, let's take a GCF out of an x. Let's factor an x out. We have this. Now, from here we can use factoring. If it factors nicely, I'm going to use bottoms up just because it's what's familiar, or you can use any other way. So we're looking for what multiplies to give us negative 42, but adds to give us positive 1. So tell me what gives us negative 42. 7 and 6, but now one needs to be positive and one needs to be negative. Okay, so we got to just play with the sign right there. And I'm going to say negative 6. Now, I always check myself. What multiplies to give me negative 42? Check. But when I add these two, I get positive 1. Check. If it doesn't check out, then maybe you mixed your signs up. Okay, and then you just put it over the first term and write from the bottom up. So this one's going to be x plus 7, x minus 6. You would set each of these equal to 0. So I take the first one, set it equal to 0, and let me represent that right there. I'm going to take x plus 7 is equal to 0, and then x minus 6 is equal to 0 when we solve all of these. Well, this one's ready to go. And you can skip right to these steps once you're more practiced in it without necessarily having to do all this work. But alright, so the zeros, this is basically all the places that it's going to cross the x-axis. So at 0, negative 7, 0, and 6, this function is going to cross the x-axis. Okay, find the zeros of the polynomial function and give the multiplicity of each. So first let's just find the zeros, and then we're going to talk about that multiplicity in just a second. I'm going to set, so the first thing we're going to do is set it equal to 0. And I'm going to suggest that you factor out a negative x squared to start. And then I'm going to give you a few minutes so that you can pause it and try the rest of it by yourself. And then just check your answer. Okay, factor out a negative x squared and we get this left over. Now if I want to factor this, what multiplies to give me positive 4 but adds to give me negative 2? I'm just going to carry this over. So what multiplies to give me 4, adds to give me negative 4 would just be x minus 2, x minus 2. Okay, and then I'm going to set each one. I can rewrite this as x minus 2 squared because these two are both identical. Now I'm going to set each one equal to 0. So if I set this equal to 0, and then x minus 2 equal to 0, I'm going to get divide by negative. You just get 0 over here. X equals 0 because you'll divide by negative 1, you just get 0, and then you get the square root, it's just 0. Over here, we're going to add 2 to both sides, so we would get x equals 2. So our intercepts are 0 and 2. That's where it's going to cross the x-axis. Now let's talk about the multiplicity bit. It says multiplicity tells us about the behavior of the graph at the zeros. So basically, even multiplicity means the graph will touch the x-axis and turn around. Let me explain that. So let's say this is a 0. Let's say for our particular problem that's 2. Okay, if I was using my graph and I hit that point, it's going to turn. If I was up here and I came to that 0, it tells me I would touch it and turn back around. Okay, odd multiplicity would represent if this is a 0, it tells you when you get to that point, it's going to cross that 0. So that's what multiplicity tells us. It tells us, are we going to go to that 0 and touch and turn around, or will we go to that 0 and cross and touch? Now let's look at our exact problem and determine multiplicity. What is the multiplicity of this? How many do they have? 2 of them, right? At negative x squared, so it's had an exponent of 2, so we would say this one had multiplicity of 2. And what about this 0? Had a multiplicity of 2 as well. Okay, we're going to look at some more in just a second. Alright, find the zeros, give the multiplicity, and then state whether the graph crosses the x-axis or touches the x-axis and turns around at each 0. So let's go through those steps together. First of all, this thing is already in factored form for us, so it's halfway worked, essentially. Remember when we had to do all this solving to get to the point where we were right here? Basically, our next problem starts us here. So 5 doesn't tell us anything. This x minus 5, if I set it equal to 0, x minus 5 equal to 0, what does that give us? The x intercept of 5. And then this x plus 3, if I set that equal to 0, that gives us, I have roots at 5 and at negative 3. But what is the multiplicity of this one? Multiplicity, what's the known exponent over that? If it's not showing. A known 1, so the multiplicity is 1. What happens when the multiplicity is odd? It's going to cross. So we say it crosses. These are our notes to ourselves. We come here, for this particular root, what's the multiplicity? Multiplicity is 2, which we flip back over here, and if it has a even multiplicity, it's going to touch and turn around. So we would say touch and turn. Okay? We're going to, like I said, we'll bring all this stuff together at the end. We're learning all bits and pieces about characteristics of polynomials, and at the very end of this lesson, we're going to pull it all together and actually get a sketch of a graph. Alright, next we're going to use the intermediate value theorem to determine whether the polynomial function has a real 0 between the given integers. And I'm going to take a minute and pause off to the side and write the theorem for the intermediate value theorem, so we can look at it and use that as a reference. So the intermediate value theorem says if you have a function f of a and f of b and they have opposite signs, then there is at least one value of c between a and b for when the f of c, this is equal to 0. So the original function equal to 0 has at least one real root between a and b. So the image of this might help clear this up a bit. So say I had this function, and when I took a as the x value, plugged it in, I got negative 2, so it means my point was here. When I took the value of b, plugged it in, I got the y value of 3. Well, if I have a y value of negative 2, and then I plug it in, and I have a y value of 3, at some point when I graph this thing, it has to cross the x-axis, which we're saying this would be a c. So basically, if you're you evaluate and your y value is negative, and then you evaluate it again and it gives you a positive y value, at some point to get from the negative point to the positive point, you had to cross 0. That's all that's kind of saying. And what we'll do algebraically to verify that is we'll evaluate each of the functions. So let's look at 13. If you have your function, they say, well, do they have a 0 between 1 and 2? So let's say a is 1 and b is 2. What we would do is we want to evaluate the function at f of 1. So that means everywhere there is an x, we want to plug in put a parenthesis, and evaluate that at 1. So I'll let you evaluate that at 1. And when you get that, you should get -3. The next thing we want to do is we want to evaluate it f at 2. So do the same thing, put parentheses, and evaluate it at 2. So everywhere there's an x, you want to put a parenthesis, plug in a 2, and evaluate. Okay, so we get +10. What we're looking at is when we evaluated f at 1, we get a negative number, like this kind of example. When we evaluate f at 2, we got a positive answer. So it means at some point it had to cross that 0 to get from a negative y value to a positive y value. So because of this sign change, if it changes from positive to negative or from negative to positive, it's guaranteed. Then we would say, therefore, there is a 0 between 1 and 2, because that was the interval we tested.